Hello, welcome to this lesson of our study of PD, and specifically this one is for solving eigenvalues and eigenfunctions problem. Okay, so we'll definitely use them in solving PDs using the method of separation of variables. After this, we'll just consider another aspect that we'll need, that is the Fourier series Fourier transforms. That would help us also in the solution of PDs using the method of separation of variables. Okay. Alright, so welcome to this once again, and in this we're just going to solve eigenvalues, eigenfunctions problems, as I said. And if you have not subscribed to my channel, kindly subscribe. But if you have subscribed to, thank you, and like my video, comment, and also share it to others to benefit as well. Alright, so consider the BVP, that is y prime prime plus lambda y equals 0, subjected to the boundary value or boundary conditions y of 0 equals 0, y prime of L equals 0. Now, in which of the values of lambda will the differential equation have a non-trivial solution? Now, what this means is that for which region, is lambda less than 0, that will give us that, or lambda greater than 0, or lambda equals 0, that will give us that. So that's what the question is trying to say. And the next question is determine the values of lambda for which the BVP has non-trivial solution, meaning that find the eigenvalues. Okay. And then the third question is find the eigenfunctions of the BVP. Alright, so let's start. Now, to solve this, we said that you have to solve the ODE given. Okay, you have to solve the ODE given, that is the y prime prime plus lambda y equals 0. You have to solve this. Now, to solve this, we have to first of all use a method of solving second order ODE, which has constant coefficients. So this one, we said you assume a solution y of x be equal to e to the power rx, and you solve this by just finding the corresponding aspect in this equation. So here you have y prime prime, so we have to differentiate y prime of this, and that will give us r e to the rx, and y prime prime will just give us r squared e to the power rx. Okay, I hope this is what you have. Now, come and put the corresponding functions there. You have to put y, you have y, so you have to put y equals e to the power rs there. You have y prime prime, so you have r squared that. So just put them back in this equation, and we'll have r squared e to the power rx plus lambda e to the power rx, and this is equal to 0. So you solve this and realize that we have r squared plus lambda e to the power rx equals 0. Okay, but we have the product of two steps going to 0. You see that the first term, that is this whole thing, is 0, or this whole thing is 0. But if e to the power rs is equal to 0, then you have the trivial solution. So we don't want that one to happen. And so e to the power rs is not equal to 0. Then obviously the product of this and something is equal to 0. And if this is not equal to 0, then it means the other one, r squared plus lambda, should be equal to 0. Okay, then let me do it here. I just want to solve everything here so that we just use the solution we have here to find our eigenvalues and eigenfunctions. Okay, lambda equals 0. Then this means r12 or r squared is equal to, okay, let me go to the next page. So we have r squared plus lambda equals 0. This will imply that we have r squared equals minus lambda, and that's r12. The reason why I say 12 is we have r squared, so we have to get two values. Okay, it's equal to plus or minus the square root of lambda l, or lambda, just lambda. Okay, now we have to consider cases, because lambda can be 0, lambda can be greater than 0, lambda can be less than 0. So let's first of all case one, let's consider a case where lambda is greater than 0. If lambda is greater than 0, then minus lambda is a negative number. Okay, so if you have lambda greater than something like 2, minus 2 is negative number, then square root of minus 2 gives you 2, or square root of 2i. Okay, like that. And if, let's say, lambda is 3, we don't know, so we just consider a general case. If lambda is 3, we have square root of 3i, because it's a negative number. So square root of a negative number is just I multiplying the square root of that number. Okay, Alright, so this whole, for the first case that we see this, then it means our y of x will be equal to, because lambda r12 will be equal to plus or minus square root of lambda I. You said it will be negative, so this is what we have. So our y of x will be equal to a e to the power r1 x plus b e to the power r2 x, because we said our y of x is actually equal to e to the power rs. Now when we have two of them, then you have to combine them. This is coming from principle of superposition. Okay, so this will give us a e to the power square root of lambda I x plus b e to the power minus square root of lambda I x. And since we have i's in our exponential, the whole of this solution will tend to y of x being equal to a cos x, or cos of square root of lambda x, plus b sine of square root of lambda x. So whenever you have complex roots, use this. Just ignore the I, and whatever answer you have, that is here. Okay, here you have the square root of lambda, so you just take only this, the positive one, and come and put in terms of the cos and sine, and use your a and b, and that is all. Okay, if you want a proof to this, I have a proof to that, but then let's continue with this. Okay, so here you apply the boundary condition. The boundary condition is y of 0 equals 0. This will imply that wherever I see x, I put 0 there. Okay, like that. When I put 0 in all these, I'll have a cos 0 will be just 1, plus, and sin 0 is 0, so we have 0 equals 0. Y of 0 equals 0, so it means 0, when I put 0 here, it should be equal to that. I hope you understand, because when I put 0 here, I'll get sine of 0 times that, and that will be sine of 0, and here to be cos of 0. But cos of 0, we said is 1, so this implies that our a will be equal to 0. So our function is actually, in the first case, is actually equal to b sine of square root of lambda x, because our a is 0. Now let's look at the second boundary condition, which is y prime of something. So we have to find y prime of s, which is equal to b square root of lambda cos of square root of lambda x. Okay, and that we're saying that y prime of L should be equal to 0, and this will imply that we have b square root of lambda cos of L square root of lambda, because when I put s equals L here, we have L multiplying that. The square root is only affecting the lambda. Okay, so I can interchange them like that, and this should give me 0. Now remember, we have the product of two things giving us 0 in the first scenario as well. Cos of L square root of lambda equals 0. So in this case, it's either this is equal to 0 or this cos is equal to 0. Now if b square root of lambda is equal to 0, then b will be equal to 0, which will be the trivial solution. We don't want that. Okay, let's go and see if there will be another case where this side will be equal to 0 without this one being equal to 0. So we don't have to let this being equal to 0. We don't want that. Then it means that cos of L square root of lambda should be equal to 0. Here, the thing is, here we've already defined that lambda is not equal to 0. So here, this part wouldn't be 0. We said lambda is greater than 0. Okay, so this part wouldn't be 0. So at what condition, or in which conditions, or at what values of cos will we get 0? Okay, so cos inverse of 0 is actually, the first thing that should come in your mind is cos of what should give you 0. Okay, cos of what should give you 0, and that is 90. Okay, but then we have other numbers or other angles as well. That is the n pi over 2, where n is odd. Okay, so n is 1, 3, 5, 7, and the rest. Okay, so n is odd. When you do this, convert your calculator to radians and choose any of these n's. When n is equal to 3, you have 3 pi over 2. Cos of that will give you 0. When n equals 5, you have 5 pi over 2. Cos of that will give you 0. So this is the solution to that, and that square root of lambda will be equal to n pi over 2, then all divided by L. So it will still be, let me just do it for you to understand, okay? Then square root of lambda will be equal to n pi over 2 times 1 over L. So in effect, it's equal to n pi over 2L. I hope you understand this. So if I want to find my lambda, then my lambda will be equal to n squared. I have to square both sides. I have to n squared pi squared over 4L squared, where my n is equal to 1, 3, 5, 7, and the rest. And that if indeed lambda is equal to this, then cos of that will give me 0 for all of them. So b is not 0, but we have lambda. We've gotten lambda, okay? So for this particular case, that's the case one where lambda is greater than 0. We have lambda being equal to this, with y of x being equal to b, or yn of s is equal to b sine of n pi over 2l s, because y of s was giving us b sine of square root of l, okay, s, and square root of l is giving us n pi over 2l, okay? So you just square root of lambda rather, okay? So it's n pi over 2l. Then you put it here. So this is your solution to that first case, with n being equal to 1, 3, 5, 7, and the rest, okay? So n is odd. You can actually state it as just a statement that where n is odd, provided maybe you are submitted an assignment or writing an exam, so you can state that, okay, that n is odd. Then you give the small, or just you give few of them, that is n equals 1, 3, 5, and 7. Now you consider the second case, case 2, where lambda will be equal to 0. When lambda is equal to 0, then it means our R12, which is equal to plus or minus square root of lambda, will then be equal to 0, because square root of 0 here is minus lambda, square root of 0 is still 0, and that we have repeated roots. So our y of x will then be equal to a e to the power r1x plus b, it's r, because we don't have two values, it's just repeated, so we have that, then plus bs e to the power rx. Here r is 0, so we just have a plus bx. You apply the boundary condition, y of 0 equals 0, and this will imply that we have a plus b times 0, and that will be 0 equals 0. So a is definitely equal to 0. So you have our y of x being equal to bx. This implies that y prime of x will be equal to b, and we said that y prime of l should be equal to 0, meaning wherever I see x in the y prime of x, I should put l there, but I don't have any x here, so it means our b is equal to 0, because our y prime of l, we don't have any l or x inside for us to put the l. So this is a constant function. This is what I mean. Okay, so with a constant function, let's say we have y prime of x being equal to b. It's a constant function. So let me name this as g of x, because I'm saying g of x is equal to our y prime of x. So find g of 2. G of 2 will be putting 2 in place of x, but there is no x here, so it will still be b. G of 5 will still be 5. It will still be b. G of 7 will still be b, because we don't have any x for us to put that, so they will still be bb like that. That's what we mean by a constant function. So it means our g or y prime of l will then be equal to the b. But I think this is equal to 0, y prime of l is equal to 0, so it implies that b is equal to 0. So for the second case where lambda is equal to 0, we have the trivial solution, y of s equals 0, because the constant a is 0 and the constant b is also 0, so we have 0. The trivial solution. Okay, so the trivial solution, let me put it that way. So this solution. So the second case, we've gotten the trivial solution. Now let's look at the third case where lambda will be less than 0. If lambda, that is the third one, case 3. If lambda is less than 0, then it means our R1 2, which is equal to plus or minus the square root of minus lambda, would then be equal to plus or minus the square root of k, where my k here is equal to minus lambda, because lambda is already a negative number. We are saying it's less than 0. So it means the negation of a negative number will give me a positive number. Let me take lambda is less than 0. So let's take lambda to be equal to minus 2. Minus 2 is less than 0. So it satisfies this condition. Then when it comes to the square root side, we have square root of minus lambda. That will be equal to square root of minus of negative 2. And that will be a positive number, 2. Okay, that's why I've represented this by k. That the negation of every lambda which is less than 0 is actually k. Okay, where k is equal to negative lambda. Now let's go ahead and use this to solve our function or our equation. So with this in mind, it means that our solution y of x will then be equal to a e to the power root of k x plus b e to the power minus root of k x. And when you have plus or minus like that, they are the same numbers but they differ by the sign. Then we can use cosh and sinh. That one, so you can search on that. Okay, then plus b sinh root of kx. Okay, so you have to apply the boundary condition. Y of 0 equals 0 implies that when I put 0 here, cosh of 0 is 1. Okay, so this will imply that a plus sinh of 0 is 0, so 0 equals 0. This implies a is equal to 0. Now if a is 0, then this will show that the function will tend to be y of x being equal to b sinh root of kx, and that our y prime of x will be equal to b square root of k cosh root of ks, and that y prime of l is equal to 0 implies that we have b square root of k cosh of l square root of k, and they are saying this is equal to 0. Now I have product of two things giving 0. You see that this is 0 or that is 0. But let's consider the cosh is equal to 0. The cosh something. You can check the cosh function on your calculator. The cosh of nothing will give you, there's nothing there that you have the cosh of it that will give you 0. So this will always not be equal to 0. So you can check this by using your calculator. Press on the hype. That is a hyperbolic function. Press on the hype, then you click on cosh inverse. Then you click on cosh inverse of 0. You see that the results will be infinity, or you have math error, meaning you don't have the cosh of anything that will give you 0. Okay, so it means this is not equal to 0. This implies that the only thing that should be equal to 0 is b root k, because you have the product of these two giving me 0. It means if this is not equal to 0 or this is never 0, then b root k should be equal to 0, so that their product will give me this 0. And this will imply that my b is also equal to 0. So for the case 3, we have y of x. Also, because b is 0 means that from here b is 0 means that y of x is equal to 0. So for the case 3, we have the trivial solution again. Okay, for case 3 where lambda is less than 0. Okay, now let's go back and check something. For the first case, or for the second case, you have the trivial solution. That is the case 2 where lambda equals 0. We have the trivial solution. In case 3 where lambda is less than 0, we have trivial solution as well. So let's go ahead and answer the question that was being asked. Okay, I hope the solutions, you have them, you've written them somewhere. The first one is, in which of the values of lambda would the differential equation have a non-trivial solution? Now from what we did, the part that gave us the non-trivial solution is only this part, the case 1. Where is it? Where lambda is greater than 0, we have non-trivial solutions. That is these ones. This is the solution we had for it. So the first thing you have to answer for the first question, saying that in which of the regions, so the first case A is the values of lambda for which the differential equation have a non-trivial solution is when lambda is greater than 0. That is all. That's the first case. Now the B is find the values of lambda. So the values of lambda, or determine the values of lambda. So it means the eigenvalues. The values are lambda n is equal to n squared pi squared over 4l squared, where n is equal to 1, 3, 5, 7, and the rest. I said you can state that where n is odd, as you can say n is a positive odd integer. Okay, that is what you should remember. Then the C is we are supposed to find the eigenfunctions. Okay, the solution gave us y n of x is equal to b sine of n pi over 2l then x. Okay, with n being equal to odd, positive odd. Okay, this means that our eigenfunction is yn of x, and it should be equal to, I said you have to make b the constant 1 sine of n pi x over 2l. Okay, with your n being equal to 1, 3, 5, and the rest. So the eigenfunctions are yn of x is equal to sine of n pi over 2lx. Okay, so that is it for this solution. Thank you, and don't forget to subscribe to my channel if you have not subscribed. If you have subscribed, thank you again, and also like my video, share it, and comment as well. See you next time.